Hello, everyone. It's really exciting to be here. So, as Adrian said, my name is Riyanat. I go by Ri for short, and I'm an engineering team lead at Turntable. So I basically wear a few hats. I do some strategic thinking. I work very closely with our software engineers. I have a software engineering background as well. But this is just one of the few projects that I get to work on with the DevOps team. So today I'm going to be sharing a few of the lessons that we have learned while deploying our CICD infrastructure and migrating our in-house applications over. So I'd like to share a little bit about Turntable, and the whole goal is not a sales pitch, but more like to just bring the whole thing together to share like why we're doing this, like why are we migrating over and why are we like building out our CICD infrastructure. We are a software consultancy based primarily in Ghana and the UK. We have a network of clients, mainly in the finance and investment space, and we've got about 200 software engineers, which is very hard to believe because we've been about for about 3 years, and we started off with about 16 software engineers. So what we do is we run a training program for 4 months. Our software engineers, we generally target graduates, but we do have some experienced hires. The training program is core CS, computer science. And after that, we place our software engineers either with one of our clients or in-house. So just a breakdown of what they do, which will bring us to like, well, why are we building out the CICD infrastructure and who is it for? The infrastructure we're building out is for the 25% over there. So let's start with the 50%. With the 50% of our software engineers, that's like half of our workforce, they work very closely with our clients. We do not need to build our infrastructure for them. Why? Because they work on projects, they are integrated onto projects on our client side. But we do have 2 in-house departments. One is our research and development department, and the goals, we're still getting there, is to do lots of R&D, prototype potential software applications that we could commercialize. But it's generally very low traffic, they're microservices, generally some 3-tier applications. And then we have our training program, which I also oversee. About 50 people, more microservices that they get to build towards the end because they do a final project. Since we're in the investment and banking space, they get to build out a trading system, so they get placed on teams. It's quite fun. And they get placed on teams, they build out a trading system, a few microservices, PubSub here, queue there, and that's mainly for educational purposes. So the infrastructure that we're building out is really for our in-house teams. The goal is that it can support about 100 software engineers. We're not quite there. And then our key objectives. So we started this project about a year ago. And prior to that, we had our software developers just deploying anywhere. So they build their little applications that either deploy to Heroku, that liaise very closely with our networks administrator, who might like provision a VM for them to, like a web service for them to like run their application on. So we just had developers just doing their own things. Some developers knew what they were doing, and others, it was pretty much just like winging it. So getting things into production was like relatively hard. We also had some instances where keys were just being leaked on like GitHub, like people just putting things into version control. So that wasn't so great. And so for us, when we started out the DevOps team, given that a lot of our software engineers are associates, we thought, right, whatever it is that we're building has got to be simple. It's got to be sustainable again, because again, the software developers who are going to be working on the project, building out the infrastructure, will mainly be associates. And scalable. We grow very fast. Like I said, we had 16 3 years ago, and now we've got 200 software developers. So the team, I promised the team that I will have a slide and that I will go to the stands and get free t-shirts. So I do apologize for my behavior in future if you see me like holding 5 t-shirts. We are spread across the UK and Ghana, as I mentioned. We've got to the left, Providence, Israel, and Vincent, and Anna is here in the audience, myself, and the network administrator. So I'll now start with sharing some of the lessons that we've learned, and I've grouped them into like 5 categories. The first one is around architecture. So we have 2 offices in Ghana. So we have our office network. We use AWS as our cloud platform. And so the first thing was like making sure that everything can connect together. And also like when we're here in the UK, like we can connect to the office network, we can connect to our resources while working remotely via VPN. So first thing first was like prototyping. which is very obvious because it's like, well, you prototype first. But one of the big lessons was don't forget to automate afterwards. So typically you might spin up a VPC, create some subnets, etc., and not automate afterwards. Or you have your initial. So we use Terraform for deploying everything. We start by using Terraform and then we start making tweaks on the AWS UI and not updating, not version controlling things. So that was one of the first lessons that we had to learn. We had a few mishaps, such as getting ourselves locked out of a very crucial like EC2 machine and having to like reconfigure everything all over again and realizing that half of it was automated and half was not. That was basically our GitLab server. Okay. So another lesson was maximizing our private subnets for us. Initially, we'd have a mix of things in the public subnet, so things that were accessible from the outside world, which didn't necessarily need to be accessible. And so we have a rule of thumb now. Everything goes into private subnet unless it needs to not be in the private subnet. So it's private by default. But that also means another thing. It means that those resources need to be able to access those resources. For example, the machines that we have in those private subnets need to be able to access the internet. For example, GitLab server, which we use for like deploying our applications, would need to download dependencies from Maven Central. So now that everything's in the private subnet, we need a way for those machines to be able to like download things. And generally, irrespective of what cloud platform they use, whether it's AWS or not, there are networking devices that you can add to your infrastructure. For us, that's NAT gateways, which is also like a learning lesson for us. Use managed resources. Like a lot of cloud platforms will provide options for you. So you could have, for example, a NAT gateway or a NAT instance, which you could configure on your own. But if you don't have the experience, you can definitely leverage managed resources, which we did. That also then presents another problem of costs. So again, what we learned very quickly, again, leveraging a lot of the things on AWS is that we could have VPC endpoints, which are a special way for us to connect to AWS resources by bypassing the gateways. So again, dropping costs for us. And then the third layer, so I didn't mention a crucial thing. Okay, so K8s, this is Kubernetes conference. So in the clusters, in our private subnets, as you can see, we've got a few resources. We've got a Kubernetes cluster, GitLab server, a few RDS clusters, one that's used by the GitLab server, and that the applications use as well. And so how are our applications exposed to the outside world? We leverage load balancers. We've got some internal facing ones since, again, like I mentioned at the very beginning, that the applications that we build are really for in-house use and one or two of them are actually external. So we've got internal load balancers. It was quite comforting this morning when one of the keynote speakers mentioned that, we have a particular image in our minds of like how our cluster should look and how our infrastructure should look, but in reality, a lot of teams don't follow that. An example like for us is we do not have a service mesh a service mesh at this point. We don't use Istio just yet. We use Ingress Nginx controllers, which basically runs as in pods within our cluster. And we have a load balancer sitting like in front of that. And then when traffic's routed to the load balancer, that's routed to the Ingress Nginx controller pods, and the Ingress Nginx controller pods pick up the traffic and route it to the right applications, basically. We have a few load balancers here and there, and they're relatively not that expensive, which is great, which works very well for us. And maybe in the future, we will migrate over to something like Istio. So right now, no sidecars for us just yet. And our DBSs, our databases are not running in the Kubernetes cluster. So just to add a final note on that, like how do we make it work? A single load balancer for serving a lot of our applications, not just one load balancer for serving all of them, but applications are grouped into domains, for example. We leverage the Kubernetes Ingress resource and define rules that leverage name-based routing. So for example, we'd have everything.env.company.xyz routed to a particular load balancer that will route it to the Nginx Ingress ingress Nginx pods, and then they will figure out that myapp.end.company.xyz needs to go to the service called myapp. Okay, so some other resources which we leverage: deployments, HPAs. Like I mentioned at the very beginning, we have a lot of microservices. So typical Kubernetes resources that would be used for microservices: config maps, secrets, and the ingress, which I just showed a moment ago. So just to summarize, in terms of lessons that we learned around architecture, it's not really just about prototyping, because that's like the obvious thing, but really that we automate afterwards and we don't just spin up things manually on our own. The second one was around automating developments, or the second set of lessons were around automating our developments. So what do? I've spoken about GitLab Server, and I've just made an assumption that we all know all the functionality, but I'll just explain a little bit. So our developers start off with local development. We use GitLab as it's like a one-and-all application where that for version control. So just like GitHub, there's a feature element in there, it's just like GitHub, but also just like Jenkins, where you can create pipelines and use that to like deploy your applications all the way through the various environments that you have and through to production. And here's where we leverage Kubernetes a lot. Not only is it the environment where we deploy our applications to, but the runners, so our GitLab runners also run within Kubernetes, and that relates to scaling, which I will share in a moment. We publish our images on ECR. Again, we leverage AWS. They are our cloud platform of choice. And we have namespaces per application for our application. Yeah, namespace per application. Okay, so what does a typical repo look like? This might be familiar to a lot of you. We use Helm. But I did mention, so again, like our three goals: simple, sustainable, and scalable. 3 S's. We could use Helm repositories, but we've chosen not to have the configuration files actually in the repo. And why? A learning component is really important, is very important to us as an organization. So by abstracting, Helm is new to a lot of our software developers, but by making that abstraction and allowing them to just pull from a remote repository and just having all of this packaged, takes away from that learning experience, and then it just looks like magic. And we wanted to avoid that. We didn't want things looking like magic at the moment. So we have our Helm directory, the chart, 2 environment values files, and the resources that I've just showed. And like this is just typical like for a Java app. So how do our deployments work? Code gets built, tested. Publish is where the application, the image is created and deployed to dev, and after dev, if that's successful, deployed to prod, if it's the main branch. But we've left this down to our teams because we've said like, hey, what we want to do is promote a DevOps culture. We want to build out workflows, applications, and tooling for you to use, but you get to define the processes and the right one that works for you. So for some teams, they might say we want to do it on a branch basis where we would have a branch called dev, we would work on features that gets migrated, that gets merged into dev, and then they would deploy to the dev environment. And for some, it's like, no, the only things that go to prod, everything must be like merged into main first before it goes into prod. So we've left an element, just to summarize on that, we've left that for the teams to define, but we've created the workflows and the applications for them to deploy their applications. So this is a typical example of what our GitLab CI file looks like. So if you're familiar with Jenkins, almost the equivalent of the Jenkins file, but not in Groovy, just as pure YAML. As you can see, you've got the different stages. We've got build twice there. It should only be like build and test, but hey. And the publish phase and deploy to dev. So pure YAML, some scripts here and there just to make some abstractions and to make things a little bit easier for our devs to slowly onboard themselves into. So for example, where we've got push, we've got some of our scripts running in the background where we just handle pushing the image over, like building the image and pushing that to AWS. And some nice integrations between the cloud platform of choice, in our case AWS, the user management, so everyone has a Google account internally, and giving them access to the actual cluster using the right cluster role and leveraging RBAC. And there are loads of like authentication tools that you can use like for command line, like doing the integration. In our case, like you've got Google accounts, people can assume IAM roles and access the resources that they have that we've granted them access to. So our choice is the AWS Google Auth, but there are a few out there. I think there's AWS ADFS as well. Okay, and finally on this, again, we're starting out simple and building our way up. Kubernetes dashboard, I totally recommend. And at the moment, we're not doing like centralized log collection using Splunk or anything fancy or Elk. At the moment, this suffices for us. It's all about the learning experience as well as building to a point where we can scale. So our developers have access to the Kubernetes dashboard, which they can use. A lot of them aren't quite comfortable or like familiar with the Kubernetes command line, but we've started running some workshops to get people onboarded, which is quite fun. On lesson 3 is scaling. So we scale in 3 different areas. We scale our deployments, we scale our cluster nodes, and we scale the applications, which is rather typical. One that I found very interesting more recently is scaling our deployments. So initially we started off with having a single GitLab server, a single runner with a few executors on the runner, and we could have a maximum number of jobs running in parallel. So one deployment, so a single pipeline, would have 5 different stages: build, test, publish, deploy to dev, and deploy to prod. Each of those are a job. Now, when we started off with just having a single instance running those deployments, things got slow very quickly, having 5 builds just in parallel. And that was not good because we needed to be able to scale this up to, like I showed at the beginning, 10 teams for our research and development and another 10 teams for our in-house training. So we started to explore other options. And one of the options that really looked good was using the Kubernetes executor, which GitLab provides. And that's basically running the GitLab runner in the cluster, and that will start up other pods for each job, and you can set a maximum in the cluster as well. So really what we're leveraging is nodes that we already had running for our applications. And we can get very clever like with creating node groups and then pushing those pods, labeling the nodes in that node group and then pushing those pods specifically to those nodes. But at the moment, it's pretty much just running on any of the nodes where we would have an application. But this for us was really good because all of a sudden we could scale our deployments. Like I mentioned, our training program, which runs for 4 months, we have that last quarter where there's a spike and everyone's like building their applications and trading against themselves, like we call it a trade wars. We can scale the number of deployments that we have, which is fantastic. But we had some problems, which we're still trying to figure out with running Docker in Kubernetes. It just doesn't work as we expected it to work. So one of our developers has started to explore Canico, and we're still seeing where that goes. But I totally recommend exploring, like if you're not running your deployments in Kubernetes and you're looking to scale your deployments, you could consider it. So a graph. Initially, when we started out, we could only run 5 deployments at a go, which was not great for us. And now we've done some optimizing, and we had 30 deployments running in parallel, and that took about 5 minutes per deployment, which was great. So that was a great place for us to be. And finally, scaling our actual cluster nodes. So again, interesting learning experience. So scaling by CPU memory, that makes sense, but one thing that I found very interesting was our network interfaces, because each of the pods in the cluster needed a private IP. And this is something that, from a developer's perspective, when I have worked on Kubernetes, I've not had to think about this layer. But all of a sudden, I'm posed with the challenge of what instance type do I select for the cluster nodes, because that's really important, not just from a CPU perspective and memory, because even if we're not maxing that out, we get a limited number of IP address, a limited number of potential, in the case of AWS, elastic network interfaces that are going to be attached to that node. And all of a sudden, I'm limited in the number of IP addresses that I can actually have on that node, even if there's lots of CPU and memory. So that was quite interesting to find out. So totally recommend, don't miss that out. In our case, we had to do some thinking, but one thing that is available is the cluster autoscaler, which some of you might be familiar with, and that has helped. So what happens is we have the cluster autoscaler, which is an application that runs in our cluster. That also discovers our nodes within the node group which we specified, and that would check the resources. Well, actually, what that checks is just if a pod, to my knowledge, in case there are any gurus in the house, but to my knowledge, what that checks is if there are any pods that need to be scheduled, irrespective of the reason why they need to be scheduled. And if it finds out that there are pods that need to be scheduled, it scales up, and it also does some computations in the background to figure out if it just needs to move some pods over and delete some instances. So that's worked out very well for us because we've been able to save some costs. And then finally, how do we scale up the applications, typically using a HPA resource, horizontal pod autoscaler resource, and that's based on CPU and memory. But that's just like for the actual applications that our software developers are building. Costing. Yeah, we've been through quite a few exercises on costing, and I'd like to share what we've learned. Initially, I thought EKS was good. So EKS, and I feel I probably should have mentioned this a lot earlier, but is the managed Kubernetes service for AWS. That incurs some costs, but it's really not that expensive, at least from what I've seen in our bill on a monthly basis. What we get charged for EKS is less than $100. What we pay a lot for are the instances that we have running in our cluster. And the other resources, our VPC, the network devices that we've all got in the cluster, the NAT gateways, which can be very expensive, the transit gateway, which I didn't mention, but connects all of our different networks together. Per attachment, that starts to get quite pricey as well. Again, slightly under $100, but it all adds up in the long run. So for us, as a small to medium-sized business, Kubernetes itself is not really that expensive for us. What is pricey are the other things that make up the whole ecosystem, like our GitLab server, like the backups that we do. It's the simple things, like doing lots, so we do very frequent backups, I think, on an hourly basis. One lesson that we learned, which is not on here, is know your cron expressions, because we ended up doing backups probably every 5 minutes, which was not intended. Was it every 1 minute, and just like flooding S3 with so many things, and then having like a very expensive bill at the end and lots of traffic going out of the network to S3. At the point, we were not leveraging VPC endpoints, which would bypass our gateways. So we were getting costs from that, from our NAT gateway, costs from S3, and emails from management. Scaling down our cluster during off-peak hours, this is something that we're still going to start exploring. But overall, what was I going to pinpoint? The cost doesn't come from running Kubernetes, it really comes from everything else. And this was just a breakdown, but I feel like I've talked about this. So for us, we have about 2 to 3 nodes. Pod capacity, again, not just based on CPU and memory, but the actual private IPs which we can have per pod. Our load balancers are cheap. On AWS, they're about $15. It's not so bad, and we don't have a lot of them. So that works well for us. S3 with a star there, I've already mentioned the story, the transit gateways, etc. And GitLab. I think the lower bullet point is a lot more pricier than what we have running for our clusters. So when we say like our bill at the moment, it's about $1,500, which we're still trying to get like lower. But our resources cost at a max of like $1,500. Again, we're a small organization. I know some of you might be like, well, we're going to have a lot more nodes and we're going to spend like thousands. But yeah, you can. So my point is, and my message is that you can start small and you don't have to break the bank. And my final one is monitoring and recovery. So this is not really on lessons learned. So this is more like on lessons learning. So we've started again with Prometheus and Grafana, still exploring the things that are important for us to be able to tell. So our builds, our jobs, we want to know how long they're taking. We don't want to have to like troll through logs. We want to be able to easily figure out, have all that data collected centrally and visualized somewhere, and we've started to explore with Grafana. We want to know when applications in production are up. We want to like be able to like check the health checks of our app. They're constantly ping performance as well. I mentioned we're building a lot of microservices, so it's very important for us to know like the latency of the requests, the level of like the number of like HTTP requests that are like failing, so we can actually speak to our developers and know when things are down, if it's our fault especially, which has happened a few times. So, and to also know just the health of our cluster. And in terms of backup and recovery, again, still exploring on the K8 side, but I feel like we're very solid on the GitLab side. So we have those very frequent backups, DB snapshots as well, and we're all good in that sense. I think, so we're going to start, so we found something called Valero, which we're going to start having a look at, and that might be able to help us with our EKS cluster backups. In particular, maybe spinning up new clusters, we could just like restore an existing one. So what do I want to say about monitoring? For us, the lesson that something that we found is that there are a lot of free templates out there. You don't have to build out all your own Grafana visualizations, which a lot of you probably know, but this for us is great. And again, still exploring. We have a version of Grafana running, but we'd like to productionize that and have data properly persisted, which we don't quite have at the moment, but en route to getting there. So, to wrap everything up, what are the key points I'd like to mention? Learners, for us, we've not just built out our entire infrastructure, made it perfect before doing any migration. In fact, like we have done a bit of both, built out some of our infrastructure, learned a bit, built out some of our infrastructure, and then migrated over some of our teams. Also learned from that, improved things, and it's basically very iterative. Automate all the things. Yeah, we have a few of those stories of just, we always start off well, infrastructure as code, Terraform, and then adding tweak functionalities here and there on the AWS console, and then not adding that to Terraform, then running the Terraform, applying, and then deleting things like our route tables, which is not good if everything is in the private subnet. And Anna is laughing because she knows exactly what I mean. And then our costing, a little here and a little there. At some point, our bill just grew, like I mentioned, but there are things that you can do to reduce the cost. So I would totally recommend keep an eye on that and don't just leave it to others to do. I think that's it from me. I am happy to take questions. Thank you so much for attending. This has been really nice to share. I hope that for some of you, it might either resonate. For some of you, you might be, I already know that. And some of you, it might inspire you to start doing your own experimenting on Kubernetes. But that's it from me. Thank you.